Kia ora, welcome to our video today, which is exploring how to write an algorithm for the first time using Dinosaur Steps. You can see that we've set up a challenge on the board, and there are the start flags and the finish flags, so we know where Explorer Ed is going to begin and end. And we've put 2 dinosaurs on there for him to visit too. When you're first starting out, you will probably start this journey without the dinosaurs on them and slowly increase the numbers of dinosaurs to visit to make the algorithm challenge more difficult. What makes Dinosaur Steps different to other processes and techniques that are out there is we have broken down the process very clearly into individual steps. So instead of writing an algorithm now, what we would do is get the students to use the footprint cards to help to plot the path from start to finish, making sure that Ed actually touches the dinosaurs or visits the dinosaurs on the way round. Now, you will note that there are many ways to solve this challenge, and students, when they first start out, can actually decide how they want to do this. They could go in different paths, they can go in different directions if they want to, but you can see that I'm using the footprints to help to plot the path that I intend to take for this solution to this challenge. Once I've plotted the path using the footprints, the next thing to do is to use the algorithm cards, and you can see the blue arrows, and depending on which way they face will depend on the movement on the actual board itself. Now with Dinosaur Steps, the command arrow means that they will be moving one whole step in that direction. There is no turning or rotating in Dinosaur Steps because we've aimed this at younger students or students who are starting to code for the first time, and we didn't want to increase that complexity by adding rotation. So therefore, this means that if it is an up arrow, they're going to be moving one whole step forwards. If it is obviously to the right, then they're going to be moving one whole step to the right. Same as down, one whole step down, and to the left, one whole square across to the left. So what would that look like? Now, when students first start to code, you may find that they actually place the command cards on top of the footprints. So they may do something like this. Well, we're going to move across. So I'm going to go down, down, and then we're going to go across. And then we're going to go from here, we will have moved across. So I'm going to go down, and then I finish obviously on the square there. Okay, and this is a great starting point for students who have not done any kind of algorithm writing before. What we want to do though is we want to then convert them into writing the algorithm as a separate set of separate instructions. So students can actually then move this across, or this could be how they start if you've got older students or students who have actually been doing this for a little while. And you can see that the command cards are now moving across to the other side to actually write a complete algorithm, a complete set of sequential step-by-step instructions. Once you have done this, students can actually start to test, but before we do that, we need to ensure they know where to start reading the instructions from. Now, if they have written vertically, obviously this means that they could start from the top or they could start from the bottom. If students have written the algorithm horizontally, then they could start from the left or could start from the right. So this is why we have our play run icon, and this directly connects to the play run button in the ByteEd app. Place this at the beginning of the instructions so we know where to start reading from. And then students can test and trial their algorithm. So this one's saying move right, move right, move down, move down, move right, move down. And you can see we've successfully gone from start to finish and visiting the dinosaurs. To make it more complex, you can add more dinosaurs on there or watch some of the other videos for other ways to create algorithms and algorithmic thinking.